get on with part 2. What we're going to do here in part 2, we're going to take the component lengths that we worked out in the first part for the common rafter right angle triangle and for the hip, and we're going to fit those components on the steel square. And the way you sort of think about that is that the right angle represents the corner of the steel square. It's just a good thing to have in the back of your mind that that's the way it sits. We need to get the measurements here onto the two sides of the square. So I've done a bit of a table here for part 2, just to help us work our way through it. We're going to identify the component lengths, the half span, the rise per metre at 24 degrees, the pump up to the true length per metre for the common rafter, and the same for the hip. And we're going to put the lengths in to the table. PLE, plumb bevel common rafter, level bevel common rafter, edge bevel common rafter. And then PLE again, plumb bevel hip, level bevel hip, and edge bevel hip. And finishing off with 7 and 8, face bevel purlin, edge bevel purlin. We need all of those angles to make the cuts on our timber to construct the job. So to start with, looking at the plumb bevel common rafter, if we come back into part 1 and we look at that representation of the true length common rafter, we can see that that top corner forms an angle between the rise and the slope of the common rafter for the plumb bevel, and it also gives us the level bevel. So the two components that make that angle for us on the steel square are going to be the rise per metre, the 445, and the half span of a metre. So what I'm trying to do is represent the 445 on this component that's only 350 long, and I'm trying to represent the metre on the blade component, which is only 550 long. Well, that's okay. I'm going to reduce those in size so I can use the measurements on the square. So what I'm going to do, knowing the plumb bevel common rafter is that top corner, I'm going to put the largest measurement of the two components on the blade. I'm going to put the metre on the blade first. So I'm going to multiply a metre by 0.3. 1 times 0.3 gives me 300. So on the blade, I want 300 millimetres for plumb bevel common rafter. On the blade, that 1 metre is now being reduced by multiplying it by 0.3 to 300. I'll do exactly the same thing with the tongue. If I multiply that by 0.3, I've got to multiply the other side by 0.3 to keep it all equal. So 445, 0.445 times 0.3 equals 134. 134 will go on the tongue. And of course, the plumb bevel of those two components, now 134 on the tongue, measured from the outside corner, and 300 on the blade. The bevel will be found on the tongue. Plumb bevel common rafter rests here. So the bevel will be found on the tongue. Isn't that fantastic? And that's a bit of a gimme now. That's a bit of a gimme for level bevel common rafter. The two components are exactly the same, but now the bevel is found on the blade. Because that's the plumb bevel, number 1, level bevel's down here. Still got the 134 on the tongue, it's still got the 300, and level bevel is on the blade. And that's what the T and the B stands for, bevel on, tongue and blade. The edge bevel common rafter. Well, the edge bevel common rafter is made up of two components, and the two components are true length common rafter and half span. So I have to do the trick of multiplying them by 0.3 to, again, fit them on the steel square. And I'm going to put the longest length on the blade, and that's the true length. This is the half span's only a metre, but the true length common rafter is 1.095. So that is the figure I'm going to put on the blade, the true length of 1.095. I'll multiply that by 0.3. 1.095 times 0.3 is 329, goes on the blade. On the tongue, I'm going to want the metre, that's the other component, the half span. I know if I multiply a metre by 0.3, it gives me 300. So that's what would go on the tongue. And the bevel is found on the blade, because that's where the true length sits. The true length always denotes where the bevel is. So that's fantastic. Now we can do exactly the same thing with the hip. We can do exactly the same thing with the hip down here. We need the plumb bevel and the level bevel components for the hip. Well, there's the plumb bevel. If that line there represents the hip, there's the plumb bevel for the hip, and there's the level bevel. The two components that make that up are the same 445 rise. I'll put that on the tongue, and the 1.414 length on the blade. Just like I did for the hip. So, for the common rafter. My apologies. So on the tongue I'm going to put 445, I'm going to put the longest length on the blade, 1.414 multiplied by 0.3 equals 424. I'm going to put 424 on the blade. I'm going to put my 445 on the tongue. If I multiply that by 0.3, it's the same rise that the common rafter was, so it'll still be 134 on the tongue. Plumb bevel hip, well, that's the plumb bevel hip sitting in that top corner. Pardon me. So the bevel must be found on the tongue. The bevel must be found on the tongue. That's fantastic. And just like the common rafter, if the bevel for the hip is found on the tongue, plumb bevel for hip is found on the tongue, the level bevel for hip must be found on the blade. So I can use exactly the same two figures. And this time, the bevel is found on the blade. That's great. Really simple. Hopefully that chart's easy to read. It looks pretty easy to read. For the edge bevel hip, needs a bit of a sweep. Have to get onto that. Edge bevel hip. The two components for edge bevel hip, just like the two components for edge bevel creeper or edge bevel common rafter, were true length common rafter and half span. The two components for edge bevel hip are true length hip and plan length hip, the two same component relationships. So it's got to be 1482 on the tongue, on the blade, because that's longer than the plan length, which is shorter, 1.414 on the tongue. So I'm going to do the same thing for those two. I'm going to multiply the component, the longest component that I'm putting on the blade, 1482, and the true length in this case. I'm going to multiply that by 0.3, and it gives me 445. 445 blade. And I'm going to multiply the plan length 1.414 by 0.3 as I did before, and it gives me 424. So I can fit 445 on the blade, but I can't fit 424 on the tongue because it's only 400 long. So when you get to the edge bevel of the hip, the only time you don't multiply the two by 0.3 to change the lengths down to sit them on the square is with the edge bevel of the hip. That's when you multiply them by 0.2. You make the amount smaller. So again, I'm going to put true length hip per metre 1.482 on the blade, 1.482 multiplied by 0.2 gives me 296. 296 on the blade. I know that fits on the blade. I'm going to multiply 1.414 for the tongue by 0.2, 1.414, and that gives me 283. I know that will fit on the tongue. So now I have the two components fitting nicely. I've got the 1.482 multiplied by 0.2 on the blade, the longer of the two lengths. I've got 1.414 multiplied by 0.2 on the tongue. The bevel is found off the true length. The edge bevel will be found off the 1.482. It will be found off the blade because that's the true length. So the bevel there is also on the blade. That's great. So the last two that we have to do are face bevel purlin and edge bevel purlin. The face bevel purlin, the two components for the face bevel purlin are the rise per metre common rafter and true length per metre common rafter. Rise per metre, common rafter, true length per metre. They're the only two we haven't used together really. So I'm going to put the larger of the two on the blade and the smaller of the two on the tongue. So the 1.095 multiplied by 0.3, we're back to 0.3 again. And we know that equals 329. 329 on the blade. I'm going to multiply the rise per metre, the 445, by 0.3, and we know that equals 134. You can do it on your calculator to check. There we have those two. And the face bevel for those two is found on the tongue. Teeth. Found on the tongue. And the last one is the edge bevel of the purlin. The edge bevel of the purlin. So the two components that give you edge bevel purlin are the two we used, pardon me, for edge bevel common rafter. The two we used for edge bevel common rafter were these two. Edge bevel common rafter, it was the 329 on the blade and the 300 on the tongue. And when we were doing edge bevel common rafter, the bevel was found on the blade, the true length, the larger of the two. Well, down here, edge bevel purlin, it's going to be the 329, that doesn't change. The 300, that doesn't change. But now the bevel is found on the tongue. That's fantastic. We'll go over some more of that in the lesson. The more times you do them and the more examples, the more familiar you'll get with bringing those across and reducing the measurements to put them on the steel square. Part 3 is next. In part 3, when you come back for part 3, I'll have a mock-up 90 by 35 drawn here, and we'll use these components and we'll actually put them on the steel square and we'll mark out where each of the bevels are. 1 through 8. And that will be your guide for the bevels to cut the components. Till part 3.